Anyway, complex numbers, ladies and gentlemen.
Yes.
So this is where things start to get a little weird, if you will. What happens now, ladies and gentlemen, we only have half an hour, so I want to get this through. What happens today is that we're going to start talking about the whole other half of math, the imaginary half.
I don't want to think
That they've
well, if
hidden
it's
from
imaginary,
us?
we don't need to
It's
think
the
about
parts that you have never known about, but yet
it. I don't,
they don't really talk about. It's kind of like hush hush.
Well, good.
Kind of like Wonderland.
It is. So what we're talking about here is what's called. It is. It's an electricity. It's for ohms and whatnot. How do you solve that?
You get square root of -1.
Because you're right. Just let me walk through it. Okay?
Goodness.
Just like you would do it before.
I don't get it.
You get x would equal plus or minus, the square root of -1. But remember, the square root of -1 means what are two numbers that are identical that you multiply together to get -1? There are negative. I mean, you're about to say 1 and -1, but those aren't the same numbers. So what they had to do was come up with something. So they came up with, think about it, an imagination, or an imaginary thing. Imagination math. It's crazy. You get,
We're learning
you
about
get,
nothing.
oops, I forgot to skip the page here. You get I. I is the square root of negative.
Upside down. It's like
What's,
what's like an exclamation?
anytime you guys are done,
It's like a Spanish question.
guys. Come on. They write it in, it's the same thing, in books, and the normal things when you use an imaginary number, it's what I stands for, they usually write it as a cursive style lowercase letter. I know that an I in cursive kind of looks like this with a dot. I believe your book does an I with a little bit of a tail. Most, if you look around through books and texts, they have, it almost looks like it's been, what's it in Word where you have, bless you, italicized. Not italicized, but you know how it's like
Slant.
Yeah.
slanty, whatever that is?
Italicized.
Is that italicized?
Yeah.
Well, that's why I teach math. Italianized, right? Says the Russian. So this is just what it looks like. So that's what I looks like, okay? Now I stands for the square root of -1. Now, what you're able to do with this then is that you can take the square root of -8 and you can still simplify it. Remember when we talked about how square roots worked, or how you had learned that square roots work? You can break it apart in perfect squares, and it just, everything is multiplied underneath the radical. As long as it multiplies to -8, it still works. So what in essence you are doing is that you are breaking this into three parts: the square root of -1, the square root of 4, and the square root of 2. Because -1 times 4 times 2 is -8. Of those three radicals then, you know two of them to simplify. The square root of -1 is I. The square root of 4 is 2. So you would simplify this to be 2, number first, I, root 2. Just like we did the other day, we put the constants up front, and then you can have a variable and the roots and all that stuff. All this is allowing us to be able to do, ladies and gentlemen, is to do more. Okay? That's really all it is. And like McCann was saying, they use this in electronics. They use it through ohms and stuff like that. It's just for, what is it, resistance, I believe?
Because that's not equal.
I think it's with resistance. That's really where you're going to see a lot of it when you go into like electric engineering, mechanical engineering, things like that. In the real world, like going to the grocery store, the only thing about an imaginary number is imagine you've got enough money in your pocket to buy that extra ho-ho. or ding dong or the apple pie. You know,
I like apple pie.
or yeah. You know they used to make chocolate ones?
Yes, I miss those. Those were so good.
So, oh, we did this.
That makes me angry.
It also, it's going to let us do these equations. Really very simple. I just want to look at this one in the middle. 2x squared plus 3 equals negative 13. We set up to solve the problem just like we would normally. We move the 3. We divide by 2. We take the square root. Since we're taking the square root over the equal sign, we still put the plus minus. Earlier when I was just simplifying something, I didn't have to do plus minus because there was no equal sign. Since there's an equal, I had to put the plus minus. Okay? When I get this, then I get x will equal, well, we just did an example of the square root of negative 8. It was plus or minus 2I root 2. You'll just remember, anytime you square root over an equal, it's always got to be plus minus.
Oh, so.
Always, always, always. Alright. Try that one. I know you guys know how to solve equations. I'm not too concerned about the equation part. I think after this last one, I'm going to jump into the conjugate part, which gets a little messy if you're not
This is
careful.
messy. Do I move? Subtract first? Subtract the 147? I didn't bring my, it's 47 plus 15, right? Oh, yeah. What's negative 147 that I have
We have here, I know she's texting with the negative 49. Where's your calculator?
She's just jealous.
She is jealous.
Oh, I forgot the square root.
So let's see, 3.
I knew it was wrong.
Did you guys try to do shortcut math?
No. I use my calculator. Shortcut.
Try again.
Plums.
Is it just always with threes?
No. You can do shortcut math with anything. If it's, let's say it's 147 divided by 5. 5 goes into 14 how many times?
2.
How many are left over? 5 goes into 47 9 times. How many are left over? 2. It's just another way of doing it.
Okay, that one was.
That's why we have calculators.
Why don't they change just this in elementary?
Square root it, and you get x plus 5 is plus or minus 7i.
I didn't get
What do I do with the 5 then? Good. You put it in front or behind it?
I put it in front.
Good. He was like, I put it in front.
Wait, why is it?
Why is it I? Because it was, we took the square root of a negative 49.
So it's all, so for every negative.
Anytime you take a square root of a negative, you got to throw an I in there. An I for an I.
That's what I thought. But if it's a positive, do you take the negative and then L?
I see you.
If it's a positive, you just leave it. Like you don't do anything.
There's no I.
Don't worry, the humor doesn't get any better as the year goes by. You'll get more and more disdain for it.
So it's only at the beginning with math and functions.
And then oh, yeah.
Oh, no.
Oh, it's different. Put that in your calculator.
I'm ready for you to join us and watch a movie, so.
As we get through more and more of this imaginary stuff, we get to do more operations with it. Remember, you won't have calculators for half of your tests.
You lie.
No, I don't lie.
He really
Okay.
doesn't. Is it?
Take a look at what's going on here. I'm just adding things together, aren't I? I'm adding two groups of things. When you have things in parentheses, they're just grouped. Okay? The parentheses with addition, does that matter? No. So this is just a combined like term. What's 3 plus 6?
That's what my
What's
calculator
2i plus negative 4i? Wait, what is it?
Negative 2.
Wait, what were other people saying?
That's what my calculator said.
You won't get a calculator. You got to stop with this. I'm really getting sick of it.
No, I was just
I know.
checking.
I know, and I know the calculator does it. You won't get calculators for some of these things, okay? What's happening here is you're distributing a positive through. That's all. Same thing goes for if it's negative. You're going to distribute a negative between the two. So if you have negative 7 minus 3i minus 2 plus 4i, think of this as when you're combining like terms, when you see stuff like that, treat I exactly like you would a variable. If it was negative 7 plus, or excuse me, negative 7 minus 3x minus the quantity 2 plus 4x, you'd have to distribute that negative in both terms in the second part, correct? You do the same thing. You do the exact same thing. You treat it exactly like you would a combining like term product. So you get negative 7 minus 3i minus 2 minus 4i just by distributing through. That's what you'll forget. Treat it like you would any other distribution problem. Combine them. What's negative 7 minus 2?
Negative 9. Wait,
What's negative 3 minus 4?
negative 7. Why are we typing
Remember,
these but not the other one?
what's that?
Why are we like?
Because the other one was adding. You didn't have to do anything. Yes, sir.
Minus 7 or times.
Sorry.
Oh, okay, never mind. I'm just.
All it is it's just a combining like terms problem. Yes, ma'am.
I thought you like typing into it.
And that was the next part I was going to say. When you get done with the problem, when you're combining terms like this, the integer value goes first, imaginary second. Put the real stuff first. Then you can just think about the other stuff. But you actually have to write it down. The other thing that happens is multiplying. What do you think that's going to look like? Foil it, very good. You would foil it just like you would. Okay? You would foil it just like you would. Good old Billy Binomial shows up. You guys don't know Billy? I'll show you Billy. 2 times 3 is? 2 times positive 7i is?
14i. 14i.
Minus 6i. And then minus 14i. Excellent. This is Billy.
He's got big glasses.
Why is it squared?
What's I times I? Okay.
Good one.
So here's what happens. When you FOIL this stuff out, you FOIL it like you would normally. Now combine your like terms. I'm going to show you what happens to this x squared in a second. We have 6 plus 8i. Now, let's go back to the pure definition of what I is. I is the square root of negative 1. Therefore, what would I squared equal?
Negative. Oh, 1. Negative.
Careful. What would it be?
Negative 1.
Negative 1. Because watch what happens. If I wanted to undo the square root, what would I have to do to both sides?
Square root is it?
I'd square it, right? So if I square root of negative 1 squared is
1.
negative 1.
That's what? There's something.
Just like we did earlier. The square root of junk squared is junk. In this case, the junk is negative 1. So anytime you see I squared, what you do is you replace it with a negative 1. So knowing that this becomes minus 14 times negative 1.
Oh, no.
You're replacing the I squared with a negative 1. So what's negative 14 times negative 1? Normal 14.
20 plus 8i.
And then your final answer would be 20 plus 8i. Now I heard you say it was written backwards. And you're right. If you FOIL it out that way, your last term will be an I squared, which means you're basically going to wind up changing the sign of the last value. It's not a shortcut to it. Yes, ma'am.
So anytime you can like do I, you'll never end up with I squared.
Correct. You should always simplify the I squared because there's a little trick to why we need to know that. Okay, why we need to know that. Let me give you another one like this.
Oh, there we go. Jules, how do you should stand on it? That's not right.
Let's make them both negatives. So 3 minus I times 2 minus 5i. We'll walk you through it again. Once you do a couple of these, it might kind of be the same thing.
I don't like this.
Write it out. Don't skip your steps. FOIL it like you would long form. Minus 15. Minus 2. Now what's a negative times a negative?
Positive.
So you have plus 5 I squared. Combine your like terms and rewrite I squared as,
Negative 1.
very good. So we have 6 minus 17i plus 5 times negative 1. We all know 5 times negative 1 is
Negative 5.
negative 5.
So it's basically
So what's my final answer then?
1 minus 17i.
1.
Okay.
So
And this is a lot of stuff they do with the ohms where they multiply the ins and outs
So it just stays.
with the complex out.
So what is
So that's just the answer?
Yeah.
You don't move it over to like make it.
negative 5? Because 5 times negative 1 is negative 5.
Right. So in 6 minus 5 is 1. I just didn't write that down. Okay. What, the adding and subtracting?
No, the first. Like we did unit 0. Yeah,
Oh, the graphing
that
stuff.
was terrible.
46 something.
What was the other one?
66. Is that one? Oh, I did 2 ones. It's like, I'm not that great.
The last little bit,
You did better.
let me write this out.
History test. I did. You got an 8. That's okay.
You guys have any lessons to
Year 9. C.
right here, Shakir?
Like we had talked about with square roots. Shh, ladies, please. When we talked about square roots in denominators, that was not cool. Same thing with imaginary numbers in denominators. That is also not cool. So what we wind up having to do is we're going to figure out a way to eliminate the I value in the denominator. Now, what I want you guys to think back on is when you've learned about factoring. When you learned about factoring, you learned about foiling, you had something like this. What was the factored form of x squared minus 25? Right, you had x plus 5, x minus 5. Do you remember what this is called? X squared minus 25. What is that called? Not a perfect square, it's a difference of squares.
I don't know.
Difference of squares. A difference of squares has no middle term. You agree?
Yes.
Now, if I treat that the exact same way with an I value, I would not have a middle term. What I mean by that is, if there's something I can think of multiplying this by to get rid of the I value, meaning not having one in the denominator, I'm going to multiply by what's called its conjugate. It's a lot of fancy words for something that is very, very easy. What is the opposite of 1 minus 2i?
Negative 1 plus.
If you FOILed that out, if you just had 1 minus 2x, 1 plus 2x, would you have you would only have x squared, correct? Your middle term would go away. What you're doing is you're multiplying by its conjugate. The same exact two terms with the opposite sign. Same exact two terms, the opposite sign. But remember, we're doing this in terms of a fraction, which means you have to do it to both top and bottom.
Would it be negative 1 or 1?
It would just be 1 because you're just changing the sign. If I did it with a negative 1, if you just use 1 minus 2x and then you did negative 1 plus 2x, you'd get negative 1 plus 2x minus plus 2x and then minus 2x squared. You'd still wind up with that middle term. By not having that, if you FOIL it out, you get 1 minus 2x plus 2x minus 4x squared, and the middle term drops. You're doing the exact same thing as this, but x squared becomes I squared. Therefore, I can go away. See ya.
Can I go away?
Wow, that took a long time on that one.
I got it right away. I just didn't think it was. I didn't get it. Funny.
Therefore,
Sorry.
I can go away, then by, then I can go.
Did you just get it?
I still don't get it.
I was paying too much attention to the board.
Watch what happens.
Therefore, I.
When you FOIL out,
Oh, okay.
when you FOIL out a conjugate, you're getting rid of the middle term. FOIL out the bottom, you get 1 plus 2i minus 2i minus 4i squared.
So we foil it there?
Yes, ma'am.
Oh, goodness, I don't want to space.
What I'm doing here is foiling it. I foil it on the bottom, and I'm also going to foil it up on the top. Okay? It's okay to have the i's in the numerator. There's nothing wrong with that. That's proper. I's in the denominator, bad. Foil out the top, we're going to get 5 plus 10i plus 3i plus 6i squared. Denominator. Everybody agree that the two i's drop out?
Yes.
Okay.
Why is there 3 I at
1
the top?
plus.
Oh, it's a.
I foil 5. So my denominator becomes 1 minus 4 times negative 1. Correct. What's happening here is that by eliminating the I value, it becomes proper. But you did not, in essence, really eliminate it. You just changed its shape. That's the idea when we multiply with fractions to get rid of fractions, to do this, do that. Your denominator becomes 1 plus 4. So you get 5. Okay? The numerator is, well, 5 plus 13i plus 6 times negative 1. Excellent. So you get negative 1 plus 13i all over 5. This is the part that takes the longest to get used to. The idea of having to FOIL things out more often than you want to. Okay? That's where things can get a bit nutty. Shall we try one more?
Is that? Yeah.
I think I got one.
It's you'll pick out a pattern on this real fast when you're multiplying the denominator. There is a very nice pattern that occurs.
I know.
Yeah.
Let's square it.
You square the.
Change the sign, put them together.
Wait, if it's squared,
Yeah, for real. I know how you feel different.
So I have 3 minus 4i over 2 plus 3i. What am I going to multiply top and bottom by?
2 minus 3i.
Excellent. Multiply top and bottom by 2 minus 3i. FOIL out. By multiplying by its conjugate, we all agree that the middle terms will drop in the denominator, correct?
Yes.
So I'm just going to write 2 squared, well, 2 times 2 for the first, which is,
Can we just write?
yeah. Yeah, you're, sorry, I don't know why I was doing that. Minus 9i squared. In the top, correct. In the top, I'll FOIL out. I have 6 minus 9i minus 8i plus 12i squared. Simplify. When you do that, the top gets you 6 minus 17i minus 12.
Wait a second. We're going to do it
Oh.
square.
Oh,
Well, it's 1.
It's negative 1.
Okay.
Okay. Over 4 plus 9. And the reason that it's 4 plus 9 is because, correct. Last but not least, bless you. What's that?
Oh, the 12, 6 and the 12 are.
Square it, change the size.
This is the 12. Okay, so it's 6 minus 12, which is negative 6. Because 6 doesn't have the I within it. So it's 6 times 12. To the third, 6.
That means you did not.
Multiple numbers.
Sorry.
Please don't give us homework.
That means the
Please don't give us homework. Don't do it.
Not necessarily, because this could have been. Yes, it will. Done. Yeah.
I'm scared. Like, they said they had to take pictures of the time. What if they get with car 30? I said no swear because that's what I'm afraid of. You're just afraid about like what if I forget the car and I'm like, oh, another kid shot my mouth. And like, what if they like start screaming and kicking? I don't want that to happen. You'll do it.
That's 5 problems.
I think that's good. Just switch the hair. He says we have a fun weekend. Please don't give us. I know.
10 problems, a whole whopping 10.
That's a
Okay?
whole whopping.
10 of them. Awesome. Should be 10.
Trying to see.
26, 27, 28, 39, 40, 41, 42, 7. Oh, yes, I'm sorry, 12.
Oh, it's 12. It's not 10.
Sorry.
It's 12. Can't you just give us 5?
Okay, I'm looking.
Okay? We will continue working with imaginaries on Monday,
I don't want to.
as well as starting completing the square. Completing the square is going to be a task and an algebraic method to solve equations that you guys are going to use forever.
I won't be here Monday and dropping out of school.
It's easy. It's very, very easy.
I hate all my classes I'm dropping out.
You have to believe it.
It's not the